The injection molding machine controller, as we'll talk about it here at the DATC, is the combination between the LCD control panel and push buttons that you interact with on a daily basis, as well as the actual electronics, the computer control, even all of the contactors and things that are in the electrical cabinet together make up the control system. The job of the control system is really to operate the machine in manual mode and automatic mode. So what do I mean by that? I mean that controller is in charge of and actually makes possible the movements of the machine, both velocity control, pressure control, temperature control, positional control, and timers. All of those things are maintained by the controller. So through the LCD interface or the screen, whether it's a touch screen or a push button screen, older machines didn't have screens, and some of you might end up operating some of those that just have timers and settings. Anyhow, through those settings or through that interface that you set up the settings, you're telling the controller how to run the machine. In other words, when you go to the temperature control screen and you enter for the middle zone on the barrel a temperature of 435 degrees, you then are telling the control that that's the temperature you want it to maintain the temperature at. So it's up to the controller that when you turn the temperature control system on, it's up to the controller to turn the heater band for that middle zone on and off. And it also measures the temperature of that middle zone using a thermocouple, which is a temperature sensing device. It measures that temperature and controls whether the heater is on or not and how much it is on in many cases to maintain the temperature then at 435 degrees. So that's one very basic function of the machine controller. Let's talk maybe about hold pressure, right? So whether it's an electric machine or a hydraulic machine or a hybrid machine, somewhere the machine will have the ability to measure the current injection pressure. It will have the ability to output a signal to either an electric motor to increase its torque or to a servo control valve to increase directly a hydraulic pressure setting. And it actually adjusts those outputs until it measures that the hold pressure is set at the setting that you set on the control. So in the injection parameters screen, if you wanted to set the hold pressure to 4,500 psi plastic pressure, let's say on the RoboShop machine, you go in and change that hold pressure to 4,500 psi. When the molding machine's running in automatic mode and it gets to that pack portion of the cycle, that pack and hold portion of the cycle, and it gets to that 4,500 psi, it actually has a sensor in it that's measuring the injection force. It calculates what that pressure is in front of the screw based on the diameter of the screw, and it adjusts the power to the motor. So if the instantaneous hold pressure was at 4,000 psi and you'd asked it to be 4,500, it would increase the torque to the motor, increase the power output to the motor, pushing more force on the screw, and increase that pressure up to 4,500 psi. Of course, if it was too high, if it was at 5,000 psi, it would back off. And so it's the job of the control, through clever programming from people, to maintain the settings that we put into it. Another common example would be a timer control. So let's say for hold pressure, we have hold pressure set at 4 seconds. So we would want the control to maintain, let's say that 4,500 psi we were talking about, maintain that 4,500 psi hold pressure for 4 seconds. And because electronics are highly repeatable and controllable, the machine can maintain that setting for 4 seconds. So we sort of put all of this together. We have temperature control. We've talked about timers. We talked about pressure control. There's also velocity control. So let's say that you're opening and closing the clamp, either in manual mode or the machine's doing it automatically in automatic mode. This isn't so much true in mold set mode. It is true. The machine will be controlling the velocity, just not the velocity we set on the clamp screen, yet a slower controlled velocity. So anyhow, if we set in there that we want the clamp to open at 10 inches per second, the machine actually controls the servo motors to maintain that velocity. So it'll increase or decrease the power to the motor to maintain that velocity. And then the last thing I want to talk about is positions. This is really important for the clamp and injection portions of the machine specifically. So we're still talking about the clamp. So if you tell the clamp to open up to a mold open position of 10 inches, the machine's going to control either the electric servo motors on an electric press or the hydraulic servo control valves and directional valves on a hydraulic machine, or hybrid machine, could be a combination of the two. And it will control those actuators to open at the velocity that you specified with any pressure limits or force limits to that position that you specified. And depending on the quality of the control system and the actuators, can highly affect how repeatable each one of these things are. The ability for a machine to control a movement at a particular velocity and move to an exact position at that velocity is actually very challenging, especially under the ridiculously high forces that we put molding machines under. I mean, to ask an injection molding machine to push forward on a screw with 250,000 pounds and a constantly changing pressure and stop at this exact position at, within 1,000th of an inch, and then continue on pressure control and make that such a smooth, graceful transition is really quite difficult. It's one of the things that makes injection molding machines expensive, is the difficult challenge that it is to control these motions. So let's talk for a moment here about the difference between a set point value and an actual value. A set point is the desired setting for something to happen at. So let's talk about temperature, right? So if you set the set point at 435 degrees, like we talked about earlier, then that's the temperature you'd like it to be at. That doesn't mean that's the temperature it's currently at. So we tell the controller we want the temperature to be 435 degrees. It's going to go measure a sensor. In this case, for temperature, it's going to go measure the thermocouple that's actually attached to the machine, attached to the barrel, the point that we're talking about. It's going to measure the temperature that it currently is at. That's the actual value. So as a machine is heating up when we first turn it on, it's clearly not, the set point and the actual are not going to match. In fact, they won't even be close. If we set our set point at 435 degrees and the machine's been off over the weekend and it's 75 degrees, then we'd go and we'd see that the set point is 75 degrees, but the actual value, the set point would be 435 degrees. We turn the temperature control unit on, or the temperature control system on, and the actual value is still 75 degrees. And the machine will start to heat that up, and the goal of the machine is to get that actual value, the measurement at the thermocouple, to match the desired set point of 435 degrees. So another really important reason to have a controller, at least a modern controller, is to measure and record different process parameters as they happen on the molding machine. Things can go by very quickly. It's very difficult for us to see the exact value when something happened. It's even difficult for a controller to display on a screen something very quickly. So a lot of things, like, for example, the machine's cycle time, is something that we're very interested in, but we don't want to be standing around with a stopwatch, waiting to see how long the cycle was. One of the very important roles that a controller has is to record those things, those results of what actually happened. How much pressure did it take to perform first stage injection? What was the actual hold pressure? What was the cushion, or the amount of screw travel left at the end of hold pressure? What was the average temperature during the cycle at any given point? What was the cavity pressure? These are all very important things for us to know, because we're able to use them to diagnose, is the machine working properly? Is there something wrong with the resin? Do we have the tools set up correctly? They're all very useful tools, and some of them very specifically are very important to help us know if things are set up correctly. Now, the machine controller will record these, and each machine is quite different in how it does this, and in fact what the different variables mean. For example, cool time. Well, we have a pretty straightforward set point usually on the molding machine. Sometimes it's called something a little bit different, but there should be a control, a setting to say how long the mold is going to stay closed. Sometimes it starts from the beginning of injection, sometimes it begins at the end of hold pressure. There's a little bit of variation there, but anyhow, it's a setting that we set in there, and we say, well, what was the cool time? There's the actual value of what it will actually be. So, for example, if it's one of these machines that cool time is actually clamp close time, it starts before injection. If there was something wrong and the machine wasn't set up correct, or we had the wrong material, and the injection pressure limit kicked in and it took longer to inject the plastic than we'd expect to, then that would affect our cool time, or at least our cure time in that matter, and we'd be able to see that. Another important one is that actual first stage pressure, or first stage time. How long did it actually take? We put a limit on it. How long can it take? But we don't ever intend it to reach that unless something's wrong. So we can use that first stage pressure to see, was something wrong? So this will be something that will commonly be on production records to record and see, were these parameters, were the actual values coming out correctly? And many of these parameters are not ones that we have a setting for to go in and set some things. For example, cycle time. Cycle time is not a setting. It's the result of a bunch of other settings and actual things that happen, right? So the cycle time is a combination of the injection phase, the holding phase, the cooling phase, the recovery phase, the mold open, eject, and close phase, all those things put together, and other things as your cycle gets more complicated. If you increase the cool time, your cycle time gets longer. If you inject the plastic faster, the cycle time will get shorter. And so cycle time isn't something that we go in and have a setting to set on the controller, but it's something that we're very interested in. We're very interested in knowing how fast this machine is making parts. We want to know, is it making parts at the same speed that we expect it to when we set up the process? If it's not, then there's likely a reason. Well, there is a reason why, but there's likely a good reason why, in the sense that something is set up wrong, or something is not operating properly.
Okay, so what does this look like? This is an example of a production monitor here on the RoboShop machine. Each one of these lines is showing another cycle that's happening. Newest cycles are shown on the top and then shown down. You can pick the different settings that are shown up here. So for example, clamp pressure here, there isn't anything on clamp pressure right now, but if we wanted to take a look at seems like a lot of the common things are already taken up. So if we want to take a look at the extruder torque, we can see just how much torque is being required to perform the extrusion operation. We can also see here cycle time. So we can see there were some abnormalities here. These were actually some semi-automatic cycles that I started and stopped. But we ought to be going on a pretty consistent 29.58 seconds here, going on here out. Here we can see the peak plastic pressure, where extrusion started, cushion position, the transfer pressure, or the pressure when we transition from velocity to pressure control. And here we have the extrusion time, or screw rotate time. It's taking about 7.2 seconds here, 7.15 seconds here to run the extruder. And injection time is about 0.277 seconds right now, or it is 0.277 seconds. Here we can see we had an abnormal one. This is probably due to starting up. We'll look at it. Yep, that's one with the longer cycle time right before. So we can use these, and they're an indicator of whether the process is working in a healthy state. Another little useful tip here on the RoboShop controls is that this button over here, at least on this version of the control, if I push this button, it shrinks the screen and adds some additional information on the sides and the bottom. So the bottom is actually this same process monitor up here, but put here, and that monitor will stay there wherever I'm at. So if I go to another screen, this information stays here because it's critical for me to see. I can also see on this cycle these key parameters. And I can also see screw position, clamp position, ejection position, injection pressure, things like that. And that is useful. Okay, so here on the Millicron MTS machine, the hybrid machine, taking a look here at the, go away from it, come back to some process monitor. We're up on the settings tab. You can see here we have all the options for the things that we could record. And if you wanted to add something to it, like fast close time, come over here and add it to the list, and it ends up being on the list. These are the lists of things we're going to record. We come up here to the monitor, and we can see some average values here. You see that our average cycle time has been 22.22 seconds. You can see all these average positions, minimums, maximums, how much deviation there's been. Then we can go take a look at the trend data, and this shows every cycle, all these parameters, the newest cycle on the top. So we can see here, let's see if we take a look at cycle time. This is the cycle that I just started the machine on. It's a little bit longer, and we can see that. You can also see that the screw rotate time is a little bit different, and the cushion's a little bit different. This cycle is just a little bit different because it's a startup cycle. The screw was not started with the typical automatic settings under typical pressures. Anyhow, in this screen, along with seeing instantaneous values down here, we can see, and here's the position of the screw right now. See that going as the machine injects. Here's the hydraulic pressure, not plastic pressure, hydraulic pressure. Remember, when you're looking at this, you need to use the intensification ratio for the machine to determine the plastic pressure in front of the screw. But here's all the instantaneous parameters of where we're at, clamp position, ejection, and so on and so forth. But these values here we can use to determine, is the machine running properly. We wouldn't see a set points per set properly. Like plasticizing time is not a set point, it's a result. If I went back to my extruder settings, I have a speed of 130 RPM with a back pressure of 80 psi hydraulic pressure. And these two parameters, along with my shot size, are what determines the amount of time it takes to rotate that screw and fill up the whole shot size. So here's the settings. I want to make sure that these are right, but if we had a different material or something was wrong, then when I went here, my plasticizing time would probably be different than what I'd have recorded traditionally for the machine. And so we've been watching cycle parameters come up here for the one front piece of, we'll call it, for lack of a better term, cell phone case, tool 2. So here's the clamp side. Let's come take a look at the injection side. Injecting, hold pressure. It's the end of hold pressure, and now the screw's rotating. Recovery's done. Cooling time finishes. Mold opens. Part ejects. And then plastic injects again.
One additional point on the injection molding control is the control's ability to save programs and settings from job to job. So let's say that you have our tool number 1 in, it's the little IV strap. If you set that tool up for a particular material and settings, you'd like to be able to save those settings so that you can go change to another tool, make adjustments for that tool, and then put that original tool 1 with the loop back in the machine and be able to recall those settings that you had set so that you don't have to do the process all over again. This is good because it saves time because you don't have to redo the process all over again, but it also means that you can run the same process without a whole lot of effort. So we don't have to document every single setting on the machine that's possible. And so this is where you'll hear them referred to both as program and parameter storage, or job tool storage. Anyway, basically all this is it gives you the ability to save and recall settings for any given process. This greatly speeds up tool change times rather than punching numbers in and trying to get the settings right. Especially since for some tool you may have gone back into some page that you don't normally go to and change some setting that matters a whole lot, and all of a sudden you can't understand with changing the parameters, the main parameters that we normally change, why things are not going back to the way they were. There are still some molding machines here in Utah that don't have this ability. However, I've seen so far that there are a lot of machines that have this capability, but unfortunately, shops have not been using it. This isn't true of all shops, but certainly if you have the ability to save exactly how a machine was set up, this would be highly advantageous. Now I want to take a minute to show you how this is done, and also how you can validate whether the right program is loaded, right? So I'm going to show you those two things on the RoboShop machine as well as the Millicron machine.
Okay, so here we are on the RoboShop machine, 50-ton RoboShop machine, and I'm going to go ahead and show you how to first off check and see if the right program is loaded. So there's two ways to get here. We can either come here to the changeover tab, go to mold file, and we'll see that, or if we went home, go up here to setup, mold file, gets us the same page. This page shows all the programs that are available to be loaded. Lots and lots of pages of them that are available. Right now we just have these three that are loaded. So we've got this junk one that's in there as a distraction, this version of Tool 1, and then this other version of Tool 1 Revision 1 is a naming convention we'll use here. So we'll see down here, these are the memory spots that we can save, and down here we see current information. So this is what's currently loaded. So we have Tool 1 Revision 1, and we have some little comments here. So this is the program that's loaded. If we needed to load this other program, and if we wanted to validate that that's the program that's loaded, we could see that here. But if we wanted to load another program, like this one here, we could load that, and that will load that information into the control. As it turns out, this is the program that I want to load, so I'll go ahead and go there. We'll talk about saving programs later when we get it to the processing portion of the program. So anyhow, this is how you can show that. It's very important to be able to understand that first off, this is possible, that it's easy, and really that it's quite simple. And you need to know how to do this for running a machine, yes, but more importantly for doing any sort of a setup work. When you change a mold, you need to be able to know how to go in and load the right program. Interesting little thing to note down here, it says when I loaded this program, it actually loaded it with the heaters off. So when I loaded the program, it automatically turned the heaters off. The heaters were already off when we walked up to the machine, but programs can be saved, all sorts of things like that. The heater controls on or off, and that can wreak havoc with what you're doing. In this case, you know, maybe not the worst thing that it turns the heaters off here in an educational environment, but when you want to have a fast tool change and you want things to go right, you don't want to load the program and then have to remember, oh yeah, I need to come back here and turn the heats on. You'd rather have, it would be better to have the heats on, save the program that way, so that as you're changing from one tool to the next, you cut out a step that you need to do. Okay, so here we are on the Millicron MTS machine. We're going to be taking a look at how we see what program is loaded here and load a program on this machine. So let's say that first off, when we go home, we can go here to Data Carrier, and this is the screen where we load and save programs. Here are all the programs that are available. Up here we see the current file that's selected, and over here is where we edit when we're going to save a file. So here if we have this one, it's not the right one, and we want to load that one, we hit there and we press load. And unfortunately, this takes quite a while. But don't be alarmed when it takes this long. This is normal for this machine to take a little while to load a program. So we see here that the current data file changed. The name that's up here is the file name here, with the XML afterward. And here we can check and see that this is the right program that's loaded. We just loaded all the settings for the machine for that one. Now if we want to go back here, we would load that program again. And over here it tells us more information about it, like for example the mold number. This is mold number 2, the little fake cell phone guy. We've got this materials general polypropylene right now. This is the reprocessed polypropylene. It doesn't have a specific part number. Anyhow, we could go through here and select the right program to be able to get the settings that we want without having to fiddle with checking and making sure that we have all the parameters right. So it takes a long time to go through here and check every single parameter and make sure they're correct. If we have access controls in place, which is another thing that on this machine you'll need to become familiar with. Right now, I'm currently logged in as the administrator, but the students here, you'll log in as students, and the password is student. Student. Login failed. I must have typed in the password wrong. Student. Okay, login successful. Up here, if this log off, if this is on, it's automatically going to log off in 3 minutes from now. So this is good if you want to make a change and then have the machine log back up afterwards, so that you don't have to remember to log out. Otherwise, you can log out here, and then nobody's logged in now. And so if somebody were to go and try and change a parameter, it won't let them change any of these parameters because they're all locked out. So this is really powerful. So if you have a setup saved and you load it, and the person who's doing the tool change, the only thing that they can do is load the program. They can't change any of the parameters. Then we can have confidence that the machine's settings are the same as they were when the program was saved, which was hopefully done in a very methodical way to get the right settings, not just a sloppy setup. But when that is the case, we can be confident that the machine will recall those parameters and run as expected. As long as the material's the same, the mold temperature's the same, we have the right mold, all of those extra parameters. But as far as the machine goes, we shouldn't have all these parameters to edit. So we might want to check on a setup sheet a few of these just to make sure we have the right program loaded. So for instance, if we are running a robot, we want to just make sure that this fully open position, 12 inches, is right. So that way we didn't accidentally load a program from the right tool, but before we were using the robot and the mold didn't open as far. If that were to happen, then when the robot came down, it could run into the tool because the mold's not open far enough. So anyhow, you check a few key parameters, but you wouldn't have to go through and check every single one of them. If you don't have access controls in place so that anybody can come up and accidentally change a number or on purpose change a number, so if they were to come up and say, well, I'm going to change the transfer position because I think it needs to be different, so I'm going to change it, and I went in and changed it. If you don't have access controls in place, you don't have any control over that, so you've actually got to check it all the time, or just accept the fact that you're at risk to running the incorrect process, which in my opinion is unacceptable. So anyhow, these two go hand in hand. Saved programs and access controls. So we want to have access controls that limit the ability to change only to those who have the need to change and who are authorized to change. And so that keeps us safe from anybody accidentally making a change, because it's actually, I've seen it happen where somebody's going through things trying to figure out how to do something and accidentally make a change. We wouldn't want that to happen inadvertently or on purpose. We wouldn't want an angry employee to damage the machine, nor want somebody unintentionally to damage the machine or to create bad parts. So that's about it.